essentially the robot is blind at that moment, right? But the idea is to use its sense of touch to tell him, look, here's something that you should sort in. So he just feels it, and then he sorts it into where he goes. So if someone is interested, and I can just hand this over to you, then you just have to, do that? Yep. You just put it in there so he doesn't lose it, right? Yeah, exactly. Yeah. A bit more. Yep. Now you got it, right? He places it, and this is now basically a pick and place task that we know from industry, so the last one, that is now collaborative, right? The important thing is that this whole sense of touch basically makes it possible to interact with it, right? So he feels and understands, and also the interesting thing is, as well, right? The system knows when it's not supposed to interact. So then he reacts basically with what we call gravity compensation. So he's just very sloppy, right? And now I put him into the kind of space where he says, okay, now I don't know really what you want me to do, but if you want me to continue, then basically I just push from above, and the robot now waits to my next action. So the next thing we see is now the impedance control, right? So one fundamental thing is that this system is compliant by means of control. So we make it via software intelligence, right? The robot itself is very rigid. Can we just stop it? So you see, if we switch off the software, we engage the brakes, there is no compliance. The system is not sensitive. If we now switch on the central nervous system, the system gets compliance, right? An interesting thing is, if I push him from here, he understands he's supposed to switch, right? So you understand from where I'm pushing. It's like if I push you and you understand, I mean, we've got a code, right? By tapping, essentially. And now if I push again, where is he now? Ah, there. Now he's fully compliant in that way. Right? If I push again, totally compliant. Right? So it's like, you don't even need teach panels anymore. You just interact with the system directly without any kind of barrier in between. Right? So all this interaction we know about feedback by means of vision, by means of all the small devices we have, we just directly talk with the robot by touching it, right? And not by just a touch pad. It's by feeling forces, by physical forces. And that's essentially the basis of the system. Now let's go to the running test. Oh yeah, sure. Yeah, okay. So now the system understands essentially that here he's supposed to wait, right? And now I just tell him, okay, start it. I taught him once. Now he needs to know where's the key, because he's blind, right? We just assume it's to be blind. So now he just knows, okay, this is where the key is, and the rest you automatically learn. So we reset the brain, okay? There is no knowledge anymore. So now it's like a baby. He just knows his body, and now he's busy poking, right? And learning more and more, and obviously this can go wrong as well, right? Like with babies, they can drop it, everything can happen in some sense, but obviously it's a bit better than babies. But instead of humans who need typically years to understand these things, we can do it in maybe 20 to 30 iterations maximum, and then the robot understands how to do it. Right? So this is also quite interesting, that you can now make these assembly tasks and these force-sensitive tasks very intuitive and very safely. And now you saw he didn't even contact the environment, right? So it's really like he's trying to all kinds of strategies, and some work, some don't work, and he's automatically evaluating. Okay, this worked, this didn't work, maybe I try this one. So it's really all these things that we know from ourselves when we grew up, or maybe some of us still remember, I don't know, but I can see it now with my children how they do it, and it's actually significantly better, I must say, at the moment. But the interesting thing is obviously that we need to encode somehow what it means to do these tasks into the robot. So this cognitive abstraction is really where humans are incredibly good, right? This is where in robotics, AI, so AI and robotics is obviously very tightly connected, and machine learning really come into one view of basically creating systems that are intelligent in the physical world. And this is what robotics is essentially about. So we basically left all the old robotics of purely mechatronics, but really transformed into a digitalization. So the interesting thing is now, how can we make these things possible also by means of connection and learning from each other. So this is really what we're working on at the moment. So if one system learns it, so it's stopped, all right? Yeah. So now he's fine, he's satisfied with his learning approach, right? So he says, well, a 3 is okay, I don't need to have a 1. And yeah, obviously the next thing is, so what we would like to do is to have hundreds and thousands of these systems, right? Doing all kinds of tasks, communicating with each other, sharing their knowledge, and basically making use of it, if you want to say so, distributed, synergistic brain that shares the knowledge and really connects these systems together.